In this video we're going to prove the absorption law that A or not AB equals A or B by removing the complemented variable. If we've got, say, JC or J not C ANDed with something else like X, the complemented variable is the C, so we get rid of the complemented variable and we're left with whatever was there before. And here the D was complemented, so not D is removed. So we'll prove A or not AB is A or B using a truth table. So we'll need some columns like not A and B, A or not AB, and A or B. So whatever columns you need to prove, you can use. So we'll fill in not A, which is the complement of A. Not A ANDed with B, so you have not A and you have B going into an AND gate, so they both have to be high for the output to be high. And in the last case they're different, so that's 0. Next we look at A ORed with not A and B, and we've already worked out not A and B, so we OR A with it. And an OR function is high when one or more of the inputs are high. So the only time it's low is at the top case. Then A or B, we don't really need anything special for that. We know that's just A or B as a simple OR gate. And we can see there that they are the same. A or not AB has the same outputs as A or B, so they are identical. We'll make a slightly more complicated version. AB or A not BC, the B is complemented, so it's removed. So let's look at A and B. That's pretty straightforward. But we need to repeat the AND for the 2-bit because the C is there, so we need the 8 states. 1 and 1 is 1. A and not B and C. Well, I realised we need to put a not B column just to make it easier for ourselves. And the AND function is only high when all of the inputs are high. So if any is low, we can put a 0 on the output A not B C. And here they're all high, and that's the only case where they're all high. Next we look at A and C. So you look at columns A and column C and treat it as a 2-input AND gate. Both inputs have to be high for the output to be high. Now we're looking at A and B ORed with A not B C, which we created earlier. So we're looking at these two inputs through an OR gate. The OR function will be high when one or more inputs are high. And finally, we'll look at A and B or A and C. It's an OR function, so if any input is high, the output will be high. So you can create these truth tables to prove. You just need to create the columns that you need. So in every case, the two outputs are the same. So AB or A not BC, the not B is removed and it's AB or AC. And that proves the absorption law.